Hello, good morning, everyone. Welcome to the solutions for the homework that I had posted yesterday. This is Ratankar Rao teaching physics in international school in Bangalore. Well, yesterday I had posted the first 5 problems, MCQs, which was homework number 1, dated December 10th. Okay, now let me start with it. The solutions for this are as below. Let us work it out. I hope you all have worked out the solutions. I have not seen your replies so far in YouTube. But anyway, let me just work it out. Okay. Okay. Fine. Now, the questions that were asked were as such. The graph shows the... Oh my God, this question has been blocked with this. Okay, just give me a moment. Let me stop my video. Yeah, I have blocked my image so that you are able to see the question correctly. Right, the graph shows how the acceleration A of an object varies with distance traveled x. And you need to find what is the work done on the object. Now you see, what kind of graph is this? This is an AX graph, acceleration displacement graph. So as a result of it, when you take the area under this curve, then what you get here is nothing but A into X, you get it, right? While if you multiply this by mass, then mass multiplied by area multiplied by the displacement. What do I get here? You see, mass multiplied by area gives you force and x is your displacement. So F into x, what does it give you? It gives you the work done. So the key here is that you need to find out the area under this curve. So which formula do we use? We use the formula for a trapezoid, which is nothing but half into d into a plus b. So what is half d into a plus b? Let us explore this. The work done is equal to half into d. What is d here? D here is nothing but the length or the distance between the two parallels, which is nothing but 20 multiplied by a plus b. What is a? A is 15 and b. What is b? B is 25. Okay, which is nothing but the length of the parallel sides, 15 plus 25, which should now be equal to 10 multiplied by 40. Now, is this completed? No, it's not complete. The reason is because this is not an axis which represents force and displacement. If you have a curve which represents force versus displacement, then the area under that force displacement curve will represent the work done. While here, it is not so, and hence this cannot be representing a work done. You need to multiply this by the mass over here. So what is the mass of the object? It's already given here, which is 3. Let me substitute this, and thus here also you get an 3, and thus you get 10 into 4 into 3, which should now be equal to 400 multiplied by 3, which is 1200 joules. Thus the answer here is 1200 joules. I hope you understood this problem. Okay, let us move on to the next one. A boy jumps from a wall 3 meters high. So I do not know why does he jump from a wall of 3 meters high. Okay, not bad. From here he jumps it across. And what is the estimate? Estimate means your answer should be closer to it. That's what is called as estimate. Okay, so towards it. Now what do we have? Estimate of the change in momentum. So you do not need only momentum, you need change in momentum, which means what? You should have P initial and P final, and you should have PI minus PF. Okay, and you can always ask me, why only PI minus PF? So far we have been looking only at PF minus PI, final minus initial. If you take final minus initial, what will happen? Let us explore that also. So currently, okay, maybe you can take PF minus PI also. PF minus PI. Okay, some of them will do this one also, doesn't matter. Now what is PI? PI is nothing but mass into velocity. Some velocity. How do you get this velocity? What is this velocity? See, he just jumped. Okay, when the moment you jump over here, let me assume his initial velocity is 0. When he reaches this point, its velocity was v. I do not know what is that value. I need to calculate. Now, how do I calculate? Very easy. So we know you can use v square equal to u square plus 2as, right? Because acceleration is constant due to gravity. Thus, I can just write u is equal to 0 plus 2 into a is nothing but g, and s is nothing but h. Okay, and thus I can now write v is equal to square root of 2gh. What is this velocity? This is the velocity at this point. Then when I say change in momentum, which momentum am I talking about? Okay, it means that, so the moment he falls over here and he gets a rebounds. Now he says very clearly that he lands without rebounding, which means what? There's no rebound. He doesn't jump upwards. His velocity of rebound is 0, right? So therefore, if I take this as V1, your V2 will be equal to 0. And thus, what will be the corresponding momenta? Momenta would be MV1 and MV2. What is the change in momentum? Change in momentum would be, let me go according to you, it is MV2 minus MV1, or you can also write MV1 minus MV2. Now look at the answers here. Now when I do this method, I get MV2 minus MV1 would be equal to 0 minus root 2GH, which would be negative. So I'm not going to use this. Now I need to go only with this method. So therefore, now let us calculate MV1 minus MV2. MV1 minus MV2 is 0. So just I need to get the value of MV1. Now, what is M? M is not given to you. What is V1? Let us do that. M into square root of 2GH. 2G into 3. What is the answer I get here? So this I get this as M into square root of 20 into 3, which is 60. Now, what is the question here? Estimate, not calculate. Okay. There's a difference between the command terms over here. So which means now I will approximate this to the closest value because calculators are not allowed in your paper 1. So I'll put this as 64. So which means this is nearly equal to 8M. Okay. Now, but the problem is M is not given. Now, once again, estimate. What do you mean by estimate? You can assume. You're free to assume. Any question on estimate, it's very easy to solve. Okay. So 8M. What is M? M is not given. Let me assume. Can it be a 40 kg boy? If it is a 40 kg boy, what is the answer I get? 8 4s are 32. 320 kg meter per second I get. But unfortunately, you see, you get 5 into 10 power 0, 5 into 10 power 1, 500, 5000. I'll write down like this. This is 5 into 10 power 1 is 5. This is 50. This is 500. This is 5000. Now you see, this is 320. 320 is not there. Can I say question is incorrect? No. Because somewhere, okay, whatever value you assume here, it depends on the value you assume here. If you assume a correct value, you would have got the correct answer. Okay. Now, how much weight can a boy have? Let us consider it. Can he have? We have assumed that the mass of the boy is going to be 40 kg. But a bulkier boy, okay, can also be somewhere around 50 kg. If I take 50 kg, what is the answer? 8 into 50 I'll get. How much will this be? 8 into 5 is nothing. 400 kg meter per second I get. Can he become 60 kg? Yeah, maybe a 11th standard or a 12th standard boy can also be called as a boy only. He will not be called as a man, right? Okay, so therefore, now if I put this as 8 into 60, then 8 into 60 would be 480, which is closer to 500. Okay, why 500? Now you can always argue with me saying that why is 60 kg? Or can I? So by this method, I get the answer as 500, which is nothing but answer C. Now, if I substitute any other value apart from this value, okay, let us say, for example, I want this answer. Okay, you assume that you have got an answer equal to 50. Now, if you want to get an answer equal to 50, now what should be your mass of the point? Now, let us do that also. So now M into 40, M into 40, what M into, sorry, M into 8 should now be equal to, what was the answer you should get? 50. Let me assume you get an answer 50. Then the value of M should be equal to 50 by 8. 50 by 8 would be how much? 8 6 are 48. Then maybe 2 8 3s are 24. Nearly 6.3 kgs. At a 6.3 kgs boy, can he jump from the building from a height of 3 meters? Definitely not. He's just a small child, right? Okay, he cannot do it. So as a result of it, this would be incorrect. This would be incorrect. Now, this is definitely not possible. Okay, so based on the same argument. Now, if you look at this argument, 5000 kg meter per second, let us do that also. Okay, now if I take something like, what is the equation? I have an equation which is 8. Okay, I'll write it here. I have proved it that the second option is incorrect. Then fourth option also I'll prove it is incorrect. Okay, so here, if I write M into 8 is equal to 5000, then the mass of M should now be equal to 5000 divided by 8. How much will this be? 5000, 8, 6 are 48. Once again, it will be 6.300. That is 630 kgs. Can the mass of a boy be 630 kgs? Impossible. So therefore, both the options are incorrect. Hence, C is the right answer. I hope you understand about how to solve problems based on estimation. Okay, now let us move on to the next one. A car moves at a constant speed of 3 meters per second for 20 seconds And then east, okay, let us write down. A car moves at a constant speed of 3 meters per second at along north. Okay. What I will do is, I'll write it down here. Along north, 3 meters per second for 20 seconds. What is this now? Constant speed. Okay. So therefore, when I say constant speed, the distance moved by the person is nothing but 3 multiplied by 20, which should be equal to 60 meters. Now, at a constant speed of 4 meters per second for 20 seconds along east. Now, along the east, it moves at 4 into 20. Why am I multiplying? I'm getting the distance over here, which is equal to 80 meters. Now, what is the average speed of the car? So why did I do that first of all? The reason is because average speed is equal to total distance divided by total time taken. This is what you call as average speed. So as a result of this, now if you look at this, average speed is equal to total distance. Do not consider 80 square plus 60 square equal to 100 square. Okay, which you would be making a mistake. So what you need to do is, you need to add the total distance, which is 60 plus 80, which is 140 meters, divided by, what's the total time taken? Here 20 seconds, here 20 seconds, 40 seconds, 40 seconds, which should now be 0, 0. Then you have 7 by 2, which is equal to 3 by 5, 3.5 meter per second. Right? So the answer once again is C. Okay. Now let us move on to the next one. That was a straightforward problem. Now, a student draws a graph to show the variation with time t of the acceleration a of an object. Let's just a moment. Okay, AT graph has been given to you. What can the student deduce from this graph, and what quantity from the graph is used to make this deduction? Now, whenever AT graph is given, you cannot find the force. Why you cannot find the force? Because m into a is nothing but the force. There's no mass given here. Okay, so the force is continuously varying out here. You cannot do that. Then next is, from the graph, what is that you want to do? Now, if you find the slope, what do you get? If let me say I find the slope over here. What has been given? Area under the graph, gradient under the graph. If I find the slope, then what do I get here? I get delta A divided by delta T. Now you see, does it correspond to any value here? This is nothing but already meter per second square. And once again, second. So it doesn't correspond to any value, because if I, in a case of a VT graph, if you get a line like this, then the slope really has some meaning, okay, which will give you delta V divided by delta T, okay, which is change in velocity, which is meter per second, which is meter per second square, which gives you the acceleration. But here, gradient of a graph does not tell you anything. So there is no point in looking at the gradient of the graph. So definitely these two are incorrect. Now we need to look at this one here. Now, next is change in velocity, change in displacement. Now, if you have velocity time graph, you can find out the displacement. Okay, but here it's one step ahead. So therefore, you cannot even find this one displacement. So this is also incorrect. You can only find out the change in velocity. Thus, the area under AT graph gives you, what does it give you? The change in velocity. Okay, so I think the last question. No, we have one more. Okay, I hope you have understood this question. So the answer here is B. So sometimes what happens is we need to exclude all the incorrect options and then you have to deduce it. Okay, next. A mast is suspended from the ceiling of a train carriage by a string. Okay, you have a train. The string makes an angle theta with the vertical when the train is accelerating along a straight horizontal track. Okay. Now, the direction of the motion is not given. How do I understand that? That's a bigger question. So now what we do is, let us draw the free body diagram for this. This is the vertical. This is the pendulum. It is as the train is moving. I do not know where the train is moving, like this or like this. Right? Which direction can it move? Can it move like this? Or it move like this? Let us see that also. Now, let the angle here be theta. Now, the forces acting here is tension like this, AMG like this. Now, what we'll do is we'll resolve the forces. Along the vertical, this should be, if this is theta, this angle should also be theta. Thus, this direction, it is T cos theta. And this direction, it is T sin theta. Now, which one is an unbalanced force? See, this is an unbalanced force over here. right? Now, as a result of it, why does it force arise? Only when somebody pushes it. Now, who is pushing it? The train is moving, and as a result of it, the object is now going in the backward direction. It is something like you are now sitting on a car. Now, the moment the car starts accelerating, I said car starts. The reason is because you have been pushed backwards, right? So now, similarly, initially might be the pendulum was at this point. The moment the train started accelerating, then the pendulum goes backwards over here. Okay, because the motion of the train is in this direction. That's what you can understand. Now, what we have is an unbalanced force. I can now write from Newton's laws that T sine theta should be equal to ma. And similarly, from this diagram, you can also ascertain that T cos theta is equal to mg, right? We have one equation here. We have another equation here. Now, let me divide one by the other. When I divide one by the other, what do I get? I get T sine theta divided by T cos theta is equal to ma divided by mg. M goes away, Tt goes away. As a result of it, you get tan theta is equal to a by g, or a is equal to g tan theta. What's the right answer? C, right? Okay. But many of you will make a mistake over here. What you do is actually, you will consider this tension here and you will split this mg into parts because you had been doing this for a very longer time. Okay. Why we are not doing this part? Okay. So what can happen is if I split it like this would become mg cos theta and this would become mg sin theta. mg sin theta. Now, is a train moving like this? No. Okay. If that is the case, but what is that I need? I need the acceleration of the train. There's nothing wrong in splitting like this, but you need to know which direction or what is the thing that has been required over here. So based on this only, you need to calculate it. Okay, I think we have come to the end of this session. So well done. So you can look for more number of problems. By today evening, I'll be posting one more set of problems and try working it out. Okay, don't just look at the solutions before solving, because it will not help you in the way. Even if you see 200 videos, you will not be able to do a numerical on your own. That's the reason I'm suggesting you first start working it out. And if you commit a mistake, understand why did you commit that mistake. If you do not understand that, do come back to me. I'm happy to help you out as why did you make that mistake. We all learn only from mistakes. So do attempt it. Okay, so thank you friends for going through this video. Once again, do like, share with your friends. It's all free. And subscribe to my channel for more updates. Thank you.